Okay, we're going to do a little bit of graphing here. I think you can see what we're talking about is called a sinusoid, and we just think of it as a wave. You do sort of want to be able to go back to the unit circle. If we picture our unit circle with the quadrantal angles, which are 0, 90, 180, 270, 360, and if we know those ordered pairs, we should be able to plot a few nice points to help us sort of sketch in this graph. Now, recall that this is the cosine and the sine, so I'm looking at the y-coordinate, which are the opposite sides if we had a right triangle there. So my sine value at 0 degrees is 0. At 90 I hit the max. At 180 I'm back down to 0. 270 negative 1. And 360 I come back home. So as I go to plot these points, I should be able to sort of sketch that nice gentle wave in between all of those points. I know it's drawn for me, that's kind of cheating. But as you get a little better at this, you'll be able to plot not with too many in-between points. I call this the big five. It's the beginning, the end, and 3 other points. That's all you really have to be able to plot for me. Now I know we can get decimal approximations, so if we really had to go to the calculator and get a few, 45 is 0.7-ish, and so would all the other 45s. So that would put us for 135, that would put us here, 0.7. We would get a negative 0.7 here, negative 0.7 there, and that would really fill in our curve pretty nicely. If you prefer, say, the 1/2s, sine of 30 is 1/2, so there's one, there's a 30. There should be another 30 over here at 150, and so on. So if you really want to plot some more points, you certainly can. And I don't know, maybe your graph will turn out better than mine. I think mine's pretty good. Something else that you should be working towards noticing, this graph has rotational symmetry, so we would call it an odd function. And that might help us with this definition, or property, or identity. Okay, so if I pick any angle over here to the left, I should get back the exact opposite value from taking the value to the right of the y-axis. So if we just picked, even if you pick 45, which we've already plotted, 45 is going to give us 0.7. Negative 45 is going to give us negative 0.7. So hopefully that gets you off to a good start on sine. We will do the same thing with cosine. So again, think back to your unit circle. Where does cosine begin? 0, 1. So I say that cosine begins at its max. Oops, sorry. Yeah, 1, 0 is the ordered pair. 0 degrees has a cosine of 1. What happens up here at 90 degrees? We should be at 0. Over here at 180, we should be at negative 1. That would be the min. And then we're going to come back up again. 270 is at 0, and you're coming home for 360. So I say that it goes from max to min to max, where I call the sine graph a bump and a dip. You're going to start to notice that the cosine graph has even symmetry, because on opposite sides of the y-axis, so if we pick an angle here, pick an x, you're going to get your y value for the cosine. If you go on the opposite side and go get that y value, it will be equal. It will be the same. So even, equal, odd, opposite. And that's how that one rotates. Let's take a quick look at tangent. I am a big fan of knowing just the real basics. I know that in the 45-45, since the legs are equal in length, my tangent is 1. So I could plot 45, 1. At 0, again, back to the unit circle. So the ordered pair is 1, 0. When you do sine over cosine, you get 0. And a negative 45, let's take a look at where a negative 45 would be. Those legs are again equal in length, but this time one of them is negative, so you get a ratio of -1. Now, some unusual things happen up here and down here, because when you go to do sine over cosine, you get the dreaded dividing by 0, which means you are undefined at 90, -90, and so there's your first vertical asymptotes. And then the graph will repeat again. Now, what you want to look at here is the length of the period, or how long it takes to go through the cycle of the tangent graph. So to get one of these S-shaped curves in, it takes 180 degrees. So if you travel another 180 degrees, look at where you end up, 270. Here's your halfway point, 180. If you don't believe me, think about what the ordered pair is over there. When you do sine over cosine, you get 0 over -1, which is 0. So if you start listing where you see the asymptotes, you'll see that there's a pattern. And what you can really say, to sort of summarize this, is that x is at 90 degrees plus and minus integer multiples of 180. Okay? N has to be an integer. In other words, you're not multiplying by fractional parts of 180. You're multiplying by 1, by 2, by 3, -1, -2, -3. So think about if you multiply by 1, you get 90 plus 180, which takes you to here. You get 90 minus 180, which takes you to here. And I hope you can tell that from there, this pattern would continue. That's your whirlwind tour through tangent.